Welcome back to EC Concept once again. So this is the new initiative for TRB Polytechnic questions. Okay. Now we are going to see the next one. That is a 2 mark questions. So this is a very interesting question. A bar of cross-section area 2 centimeter square and length 100 centimeter, fixed at the rigid support. So we can conclude this is the bar. Cross-section area is 2 centimeter and length is 100 centimeter. Fixed at the rigid support at both ends for a temperature rise of 25 degrees Celsius. The bar is subjected to an increase in temperature of 30 degree. Now the bar temperature has been raised 30 degrees Celsius. If the coefficient of linear thermal expansion of the material, that is alpha, is equal to 10 into 10 raised to minus 6 per degree Celsius. The Young's modulus of the material is equal to 2 into 10 raised to minus 6 Newton per millimeter square. So we know that because of this rise in temperature, 5 degrees Celsius is the delta T. Okay. Because of this rise in temperature, there was a stress which was developed, that is a compressive stress, is equal to E alpha T. So E alpha T is equal to 2 into 10 raised to 6. Actually, the Young's modulus is not minus 6. This is 2 into 10 raised to, let's say, 2 into 10 raised to, generally 5 is correct. Okay, this is 2 into 10 raised to 5. There's a mistake in the question. Okay, so 2 into 10 raised to 5. So answer for this question is this. Alpha is equal to 10 into 10 raised to minus 6. What is the temperature? That is a 5 degree. That's the increase in the value. So after solving this, you will get this is equal to, okay, to 10 Newton per millimeter square. Now the challenge is, if the temperature rises, then the stress will be developed on the bar as a compression. So answer for this question is now A. Understood? So answer is A. The next question is, the maximum permissible load on a steel bar of 20 mm diameter when a factor of safety is 1.8 and the ultimate stress is this one. So they given the permissible load. Okay, we know that stress equal to force by area. Ultimate load they are asking. Now here the stress equal to 495 into area pi by 4 into d square 20 square, which is equal to P. Okay, so if you resolve this, then you will get 495, that is 495 into 5 into 20 square. Answer is equal to P is equal to, we are getting 155508.83 Newton. Then they are asking permissible stress. So therefore, permissible stress, or permissible load, which is equal to permissible load divided by factor safety. That is here P divided by 1.8 factor safety. 1.8. That is 86393.79 Newton. So in terms of kilonewton, 86.39 kilonewton. So answer for this question is now P. Okay. Next question. If two forces each equal to P act at a right angle. There are two forces which are acts at a right angle. This is one force, this is another one force. This is a P, this is a P. Act at right angle. Their effects may be neutralized by a third force acting their bisector. The bisector of these two forces is what? This is the bisector. This is the third force which is acting. This force is neutralizes these two forces. Therefore, neutralizes means this force is acting opposite manner. This degree is 45 degree. So we can say this is the resultant. This is equal to root of p square plus p square. Okay, square of these two. So which is equal to root 2 p. So the answer for this question is C. Understood? Now next question. In the bar as shown in the figure, the force in AC part. Actually, this is the bar. So the condition is, so there is a formula. If a fixed bar, fixed axial bar, subjected to a force P, and this portion is A, this portion is B, then this is RA, this is RB, this point is A, this point is B. Then we can write RA is equal to PA divided by, sorry, PB divided by L. And RB is equal to PA divided by L. So this is the answer. So you can substitute the respective things. They are asking for force in AC part. Therefore, AC in the sense here, right? AC. Therefore, RA you have to calculate. RA is the thing they are asking. Therefore, P is how much? 100 into B 600. Not 600. 450. B is 450. 450 divided by L is equal to how much? 1050. We can cancel this is 9, and this becomes 2 1. We can cancel this 3, so this is 7, so it's equal to 300 divided by 7 kilometer. Answer for this question is B. Okay, now in a two-dimensional stress system has like stresses sigma x, and another one is that also sigma x, that is sigma y. Okay, there is a mistake, the printing mistake, sorry. Sigma x, sigma y in mutually perpendicular direction. The coordinates of the center of Mohr circle. They said there is a force in sigma x is 100 like stresses. Like means it can be either tension or compression. That is the meaning of like stresses. It can be both are tension or both are compression. So this is the 200. So the center is a comma 0. The center of Mohr circle is a comma 0. Center of Mohr circle. So now A is equal to sigma x plus sigma y divided by 2. So A is equal to what is sigma x? 100 plus 200 divided by 2 is equal to 300 divided by 2 is equal to 150. So this is the answer. A is equal to this one. Therefore, center is equal to 150 comma 0. So answer for this question is C. Okay. Next question. The force required to cause rotation theta at the prop end of a propped cantilever beam. So this is the propped cantilever beam, and the span is L, length minus 1, so forth. The force required to cause rotation theta. How much force is required to cause rotation theta? So this is the rotation theta. To cause this theta, how much moment you have to apply M? M is equal to 4 EI by L. Okay, so this much moment is required to create a theta rotation. Is a theta rotation, therefore put it here, theta. Therefore, this is the answer. So answer for this question is this one. Suppose the force required if one end is fixed. Suppose this end is hinged and this end is a roller. How much force is required to cause theta? That is M. This is the theta. How much M? 3 EI by L into theta. So this is the answer. Okay. Now next question. The reaction of a propped cantilever beam of span 1 with a UDL W kilonewton per meter. Of span not 1, actually this is L. Yeah, you have to keep this formula in your mind. This is the UDL acting throughout the span. Then this prop reaction is equal to 3WL by 8. So this is the W. This is 5WL by 8. And this moment is equal to WL square by 8. This fixed end moment. And similarly, one more formula you have to keep in your mind. Prop can this is center point load W. Now this value is equal to 5W by 16. This one is 11W by 16. This is L by 2. This also L by 2. And this moment is equal to 5W by 16 into L minus W L by 2. So the answer is equal to, that is 3WL by 16, I think. Yeah, 3WL by 16. So this is 3WL by 16. So you have to keep this also in your mind. Okay, this is the directly they will ask you the question. So now here they are asking UDL W kilonewton per meter throughout the length. Therefore, answer for this question is 3 by 8. B is the answer. Okay, prop reaction they are asking. Okay. Next one is a uniform simply supported beam is subjected to a clockwise moment M at the left end. So there was a beam, simply supported beam. The left side there was a clockwise moment M is applied. The moment required at the right end of the beam so that the rotation at right is 0. So if the rotation at right is 0, then we can convert this beam as something like that. Rotation is 0, which kind of support? Having the rotation 0, fixed support. So the meaning of this is, we convert, because of this meaning, because of this given, you have to convert this roller support into fixed support. Why? Because the question said that at this point, the rotation is equal to 0. And this end is as it is. So this is M. Now, how much is the moment? Now, this is a clockwise. The same moment direction will be developed by an amount of M by 2. If we apply a moment M, then half of the moment will be carried over the adjacent end if the end is fixed. Okay. So this is the answer, M by 2. Now, next question. Two plates are connected by a lap joint using 4 bolts of 20 mm diameter. If the joint is subjected to a tensile force of 100 kilonewton, then the shear stress is what? See, so this is the lap joint. Here there are 4 bolts are connected. Okay. 1, 4 bolts are connected. Okay. If you look this in the plan, so this is the end and this also end. So there are 4 bolt, 1, 2, 3, 4 bolt. Okay. If the joints are subjected to a force of 100 kilonewton tensile, so this is the 100 kilonewton tensile. So then what is the total shear stress in the bolt? We know that this load taken by bolt due to shear, that is 100 kilonewton, 100 into 10 raised to 3, which is equal to number of bolt, that is 4, into shear stress tau into the shear stress is taking place on this circular surface area, that is pi d square divided by 4 into number of shear plane. Number of shear plane. So is equal to 4 into tau into pi into what is a d? D is the diameter of the bolt, so which is given 20 square divided by 4. So for lap joint, number of shear plane only one. Okay, one. Lap joint, number of shear plane is equal to 1. Understood? So you can cancel these two. So the answer for this question is tau into 22 divided by 7 into 400 into 10 raised to 3. So you can cancel out this. So this is 4 becomes 4. Therefore, 10 raised to 3 into 7 divided by 4 into 22 is equal to tau. So the answer for this question is 7000 divided by 88, which is equal to tau. So 7000 divided by 88. So you have to do it. This is 7088. Simply I'm giving the answer. 7000 divided by 88, 79.54. 79 point tau is equal to 79.54 Newton per millimeter square. So this is the answer. So answer is this one C. Understood? Now the next question. A timber beam of 150 mm width, 150 mm width, 200 mm depth. So 150 mm width, 150 mm width, and 200 mm depth. With the two plates, steel plates of 10 mm thickness and 150 mm width at the top and bottom. There are two steel plates. These are flexed at the top and bottom. So this is 150, and the thickness is 10, and this one is 200 mm. 200 mm. 200 mm. This is 10. And they are asking the equivalent width of the timber. So this is the timber. This is the steel. So converting this as a equivalent width of timber, then how it will go, So this go equivalent width. The width as it is, but while converting this as a equivalent width of timber, then this width of steel becomes something like that. The width will be increased. So this width is equal to actually m into b is equal to how much is the m, and m we can calculate as always you have to take a ratio higher Young's modulus to the lower Young's modulus, always 210 divided by 14, so which is equal to, so this is equal to 30, this is 2 is equal to 15, therefore 15 into 150, which is equal to 1500, 2250, right? 15 into 150, 2250, which is equal to 2250. So such option is not there. And this is 150. This is the top and bottom fletching. Okay. Suppose if we consider side fletching. Let me give the value. For side fletching, this is the side fletching. This is 10, this is 150, and this is actually 200. Okay, but anyhow, whatever may be the value, let me give the concept. So I'm taking, this is the breadth, this is the thickness of the steel, this is steel, this is the timber, this is the steel, and this is the depth. Now converting this as equivalent to, this is equivalent to wood. If I convert this thing equivalent to wood, then width, which is equal to this B plus the T steel, the width will be increase. That is how much increase? MT for this one also MT. So is equal to B plus 2 MT. So this question is actually vague in nature. This question is actually is not correct. For this case also, for side fletching also, if you substitute the value, then you won't get answer. Okay, so simply we can conclude this question is not fair. There was a mistake in this question. Okay, uh, understood, right? One more thing, let me tell you here. This is the equivalent to wood. If you want to convert equivalent to steel, if you convert equivalent to steel, this, then keep the steel width is as it is, but the width of the wood will be reduced. This is the B, but this is breadth of wood divided by modular ratio. You have to divide the modular ratio so that you can convert equivalent to steel. Okay, so but anyhow, this question is not fair enough. Okay, so they ask the equivalent to width of the timber. Width of the timber. If they ask equivalent to width of the steel, then this is the answer. If they ask equivalent to width of the steel, then you can convert what is the breadth of wood, 150 divided by modular ratio of 15, which is equal to 10. Sorry, not A, B. B is the answer. If they ask equivalent to steel, then the equivalent width of the timber segment is, okay. So, but they ask equivalent width of the timber. If they ask equivalent width of the steel, then 10 is the answer. Okay, yeah, that is a problem. So this question is, as per my point of view, there is a small mistake in this portion. Okay, the next one, this also question is a mistake question. Why? The shear stress at the neutral axis of a rectangular beam of width B is equal to D by summation. What is the meaning? Okay, in your original question also you can see this is not our printing mistake. In our original question also there was a printing mistake. D by what? Subjected to a shear force of so on and so forth. Actually, what I am feeling, this may be B is equal to D by 2. Maybe I am feeling this is the thing. So, but anyhow, let me tell you, the shear stress, the distribution is somewhat parabolic in nature. Shear stress at any point which is calculated V A Y bar divided by I B. So that is the formula. By using this formula, once you know the exact thing, then we can able to solve. Now, what we couldn't to do anything here. Okay, so this also a question error, and the question is not perfect. Okay, now next question. The maximum stress of a shaft of 10 mm diameter and 2.7 meter length subject to torque shear modulus. Maximum shear stress they are asking in a torque. We know that shear stress equal to what? 16T divided by 5D cube. Keep this formula in your mind. So which is equal to 16 into what is T? 125 into 10 raised to 6 Newton millimeter divided by pi into what is the diameter? Maximum shear shaft of diameter 100 the whole Q. So you can cancel out this and this. So what can be the answer? This is 16 T divided by pi d cube. So the answer is 16 into 125 is approximately you will get 2000, right? So answer for this question is a 2000. So 2000 divided by pi. Okay, therefore we got the answer this 2000 divided by pi megapascal. Okay. Now the next question. This question also somewhat not fair. They ask if the wind pressure at a location, that is a basic wind pressure they given. Wind directionality coefficient in this average factor, area average factor, combination factor, then the design wind pressure is. So this question, the design wind pressure PD, you have to multiply this all coefficient 0.9 into 0.8. If they ask the question for a design wind pressure and by giving any of the coefficient, you simply multiply this all coefficient. You don't want to add, you don't want to divide. Simply take all coefficient in the basic wind pressure 1000. So if we simplify this is equal to 0.72, that is 720 Newton per meter square. So this is the answer. Okay, so answer for this question is 720. But actually put note and note here, note, actually design wind pressure is equal to 0.6 V square. Okay, so this is the design wind pressure. Design wind pressure. Now V is equal to V is equal to, we can write K1, K2, K3 into VB. VB is the basic wind speed. This is the basic wind pressure. And the K1, K2, K3, they will ask you K1, K2, K3, it represents what? This is the question they will ask you. You can expect. So they will ask you what is K1, which is represented in the wind design wind pressure formula. K2 represents what? K3 represents what? K1 represents the probability factor. Probability factor. K2 represents the terrain and structural factor. Terrain and structural factor. Next one is a topography factor. So these three are the important thing you have to keep in mind. Understood? This is the, but here answer is 720. If a given, then simply multiply and you will get answer. But actual procedure is this. Okay. If you use the actual procedure, then you won't get answer. So that is a thing. But this question also somewhat vague. The question is not perfect. Okay. They simply are given the wind pressure and giving the some of the coefficient and asking what is a design wind pressure. So I'm saying if the question is such a way that then simply have to multiply all factors with the basic wind pressure so that you will get a design wind pressure. Okay, but this is the actual procedure. Okay, now a propped cantilever of span L is subjected to a concentrated load at mid-span. If MB is the plastic moment capacity of the beam, then the collapse load will be, it's a propped cantilever beam, right? So propped cantilever beam subjected to central point load W Then the collapse load is equal to 6 MB by L. You don't want to derive this. Simply keep this in your mind. And for a simply supported beam with the UDL, point load at the center W, then the collapse load is 4 MB by L. In the similar manner, fixed beam with the point load acting at the center, then what is a collapse load? 8 MB by L. So 2, the value will be increased, but all are the center load. Simply supported, properly cantilever, fixed. Understood? I hope you got it. So next question we are going to see the same kind of question already we having seen in the 1 mark. See the question. The same question they have kept 1 mark as well as 2 mark also. Okay. The base plate of your roof truss is attached to the concrete pier with the help of 16 mm diameter mild steel bar, mild steel anchor bolt. Therefore, anchor bolt is subjected to the tensile force. Okay. Fi yield strength of bolt is given. The maximum pull the base can subject to if the roof area of bolt, this is not bolt, is 0.7 times the shank area. So we know that the tensile force they are asking P is equal to 0.7 times the shank area, right? Pi by 4 in a d square into the bearing stress. Okay. So is equal to 0.75 into pi by 4 into what is the diameter? Diameter is equal to 16 square diameter of the bolt into what is the bearing stress? 0.75 times the Fy. So which is equal to 0.75 into pi by 4 into 16 square into 0.75 into 250. So the answer for this question is, after solving, we will get around 28.26 kilonewton. If you simplify this, 28260 Newton. Okay. So answer for this question is this one. Yeah. Okay. Next question. A batten column is subjected to an axial force of 1100 kilonewton. The battens are placed at 1.25 meter center to center. That is, C is given 1.25 meter. The depth of the batten and the length of the batten, thickness of the batten on two planes are given. The bending moment in the batten. So bending moment in the batten, VC divided by 2N. Here V is equal to is a transverse shear. So where V is equal to 2.5 percentage of axial load is equal to 2.5 divided by 100 into 1100. So if you simplify this, then you will get 2.5 into 11. 2.5 into 11. So the answer for this question is 27.5. Okay, this is the kilonewton. You got it. Okay, now you have to substitute everything. Moment is equal to 27.5 into 1.25 divided by 2 into number of planes 2 on 2 planes. So if you simplify this, then you will get actually now see this is 2 and this, okay, this is 27.5 into 1.25. Let us take this is the 4. So approximately this is take it as a 28. Then 7 4s are 28, right? 7 6 4s are 24. 7 approximately we can take is 1.25. So but anyhow this value is approximately you will get 7 into 1.25. Anyhow this is the 10.6, right? Yes or no? Into 1.25 divided by 4. No, 8.59 is the answer. So you are getting somewhere here. That is 7 into 1.25. How much? Yeah, it's approximately 8.6. 8.75 you are getting. That means this value is actually what? Less than 7, right? This value. So after solving, you'll get approximately this 8.6. So you have to use that uh, some small tricks. Okay. Then only approximately you can able to find out the answer. So 8.6 is the answer. Kilonewton meter. Now next one. So next question is for a long shallow grider with a low warping stiffness, the critical moment is expressed by. So this is the formula you have to keep in mind 5 divided by L EIY into GJ. Okay. Next question. The column with the unsupported length of 3.5 meter, cross section, so on and so forth, subjected to axial force, check for minimum eccentricity. For a column, we know that minimum eccentricity is equal to maximum of L unsupported length. Unsupported length divided by 500 plus TRB, least lateral dimension divided by 30 or 20 mm or 20 mm, whichever is less. So this answer is maximum of what is L unsupported is equal to 3.5, 3500 divided by 500 plus DRB. Here both are same, therefore 420 divided by 30 or 20. So the answer for this question is maximum of this is 7 plus plus 1 4. This is 20. 21 or 20. Therefore answer E minimum is equal to take maximum is equal to 21. So answer for this question is C. Okay. Next one is the stiffness matrix of a beam element is given. Corresponding flexibility matrix. One thing you have to keep in your mind, flexibility matrix, if you want to calculate the flexibility matrix, then you have to take inverse of stiffness matrix. Or if you want to calculate stiffness matrix, then you have to calculate the inverse of flexibility matrix. Meaning the flexibility matrix and the stiffness matrix product is equal to identity matrix. And the flexibility value in the stiffness value is equal to you will get a 1. So these data are important for your upcoming examinations. Okay. So in the question, they given the stiffness matrix. So to calculate flexibility matrix, you have to take inverse of this. Flexibility matrix is equal to inverse of stiffness matrix. So EA divided by 63 into 4 minus 9 minus 9 36. So this is the thing you have to take a inverse of this. So the inverse of this is equal to EI. So it's not 63 divided by EI into at GA. You know the inverse at GA. You have to interchange this diagonal 4 and change the sign. This is a 9 and this also 9. Okay. So change the diagonal, this diagonal 36 4 and change the sign for this diagonal divided by modulus of this 36 into 4 is equal to 144, right? It's equal to 144 minus 981. Okay, you know that K inverse is equal to adj K divided by modulus of K. Modulus of K. Modulus of K. Okay, so this is the thing. Now, if you simplify this, which is equal to 63 divided by EI into 36 and 9 and 9 and 4 the whole divided by 63. You can cancel these two. So finally you will get 1 by EI into 36 9 9 4. If you simplify this everything, so 36 1 by A 36 9 9 4. So answer for this question is B. Okay, so this is the answer. Now next question. So it's a very interesting question. A three-hinged parabolic arch subjected to a load W at L by 4 distance from the left support. So a three-hinged parabolic arch. A three-hinged parabolic arch subjected to concentrated load a concentrated load W at L by 4 distance from the left support. This is the W at a distance of L by 4 meter from the left support. This W is equal to they given 80 meter. Sorry, 80 kilonewton. And the span is 20 meter. 20 meter. And the crown, the central rise is they given is 4 meter. And this is L by 4. Then how much this? 20 divided by 4 is equal to 5 meter. We know that this is VA, A point. This is the B point. Therefore, this is VB. And this is the horizontal reaction HB. This is the point C. Let us consider. This is the HA. In general, HA always is equal to HB. Okay, this also you have to keep in your mind. Now they are asking horizontal thrust. For calculating horizontal thrust, first before that, we need the reactions. So that you have to take moment about A is equal to 0. Summation of moment about A is equal to 0. Assume anticlockwise is positive. Therefore, VB into 20. This is the line of action about this point. Therefore, HB will not produce any force. Minus 80 into 5. And this two are line of action about this point is equal to 0. So VB is equal to 80 into 5 divided by 20. So answer is equal to 420. This is 4, therefore 20 kilonewton. So this is the VB. Then what is the horizontal thrust? In order to find out the horizontal thrust, you have to calculate moment about C. Take moment about C is equal to 0. Assume anticlockwise is positive. Therefore, VB into 10. Okay, VB into 10, this distance, minus anticlockwise, clockwise is H. HB into 4, which is equal to 0. Therefore, HB, which is equal to VB is 20, right? So 20 into 10 divided by 4 is equal to 50. So 50 kilonewton. So answer for this question is